still trickling in. But just as a reminder today, Ben Lamotte and I will be talking about Fluree and Clojure. So some sort of from both angles today, we'll be talking about what's possible in Fluree and Fluree's capabilities, particularly how they're enabled by um, our roots in the Clojure programming language. But for folks who are possibly less familiar with Fluree, more familiar with Clojure, we do expect to have a few of you. Will be coming at, from that side as well. So you might get an intro to Fluree that'll be rooted in our foundations in Clojure itself. But yeah, we'll take another minute or two to let some people come in. And just, I guess, first of all, welcome to everyone. And, thanks for joining. And if you'll just sit tight for just one more second as we make sure we have everyone who's interested in attending in the room. I should say too, we do have just for the server for this channel, we have everyone sort of video and audio disabled, but especially as we sort of get towards the end, I think we'll leave, 15 minutes or so for, Q&A with people who are directly here and in the room. And at that point, we'll make sure we enable video and audio for everyone. There is in the community channel, there's a voice chat text channel as well. So please, by all means, if you have questions you'd like to type out in the meantime, I'll be monitoring that and we'll surface those as they come up, particularly if they engage with the conversation we're having. So while the sort of server mics are muted, please feel free to drop any questions in you have there, and we'll try to get to those even before the Q&A section at the end. Yeah, I think we'll go ahead and get started and people can join as they want. I'll go ahead and just say too that we are streaming and recording this, so it's going to be visible on Twitter and I think Twitter and YouTube and LinkedIn possibly. I can't remember, but it's also going to be recorded and it's going to be viewable for posterity's sake. So you'll be able to share this out if anyone thinks it would be an interesting conversation for anyone else to observe or listen into. But my name is Andrew Johnson. I am, amongst other things, leading these community calls, but I'm an engineer and solutions architect here at Fluree. But more importantly, today I'll be talking with Ben Lamotte. He's one of our senior platform engineers. He comes to Fluree, or has been at Fluree for quite a bit, but even before Fluree had quite an extensive background, not only in Clojure, working with the language in various capacities, but has an extensive background with concerns and software solutions that are similar to some of the concerns that we have here at Fluree. So we'll talk a little bit more about that as well. But Ben, welcome to your first community call. Yeah, and again, at a high level today, we're going to be talking about Fluree, what Fluree is and the capabilities it enables, the problems it looks to solve, but looking specifically at that from the vantage point of our code being written predominantly in Clojure, the Clojure programming language. And so we'll speak sort of from both angles on that, what is possible or more performant in Fluree because of its background and its embeddedness in Clojure. And if you're coming to Fluree knowing little about our platform or our infrastructure, our capabilities, but with some knowledge of Clojure itself, and are just interested to see what Clojure is doing for us from that angle, we'll be talking a bit as well about how Fluree does what it does, starting from the perspective of what Clojure itself is able to do. But Ben, if you want to, I'd love if you could just maybe give a little bit of a brief background of your experience, particularly if you think it'd be interesting to talk about what you've done with Clojure in the past, or, what drew you to the language in the first place and how you've used it.
Sure. So I come at software engineering from a more mathematical background. I majored in theoretical math in college, and so I'm all about writing proofs and elegant philosophical discussions and whatnot. The first programming language that I ever wrote anything significant in college was Scheme, which is a dialect of Lisp. And I just fell in love with how concise the language was and how elegant everything that all of the thoughts that you could express in Scheme were. And after I started my professional software engineering career, every company that I went to used a different, mostly object-oriented language, from Java to Ruby to Python. I also dabbled a bit in C. And all of those languages, for lack of a better term, seemed a bit dirty to me. They all did these weird things kind of under the cover that you didn't really understand what was happening, or at least I didn't at the time. They, tried to make things easier for you by doing this, magic that came up that you didn't really understand and didn't really fit. And there just was a lack of concision and elegance in both the syntax and the way the language worked. So I didn't really have that same experience and that same satisfaction working in those languages as I did with Scheme. But the problem with Scheme was that it was mostly an academic language, and so it didn't really have a vibrant ecosystem around it. And if you tried to do anything serious in Scheme, there weren't libraries to support what you wanted to do, and so a lot of times it felt like you had to reinvent the wheel. And so I just felt like I had to just, grit my teeth and deal with these languages that I thought were dirty, but they had a vibrant ecosystem around them so I could be productive in them. And then when I heard about Clojure around maybe 2010 or 2011, it seemed like the best of both worlds. It was a Lisp, so it had all of the elegance of the syntax and the concision that Scheme had, but it was built on the Java virtual machine. So I could leverage the entire ecosystem of Java. Every library, or every task that you want to do with a programming language is a Java library to do it, and I could use those libraries directly from Clojure. And so to me, it seemed like a productive Lisp, which was at that time and currently the holy grail to me. And so that from the time that I started using Clojure, I fell in love with it just like I fell in love with Scheme. And I've been doing most of my, side projects in Clojure from maybe 2010 or 2011. And then around 2016, I was able to professionally work on a Clojure code bases for the first time, and I haven't looked back since then.
So I do want to get to some of the work you've been doing at Fluree, or work that's relevant to the work you've been doing at Fluree even before that. But maybe you can speak a bit too to the specific sort of characteristics of Clojure. You mentioned, for example, its Lisp structure, and that elegance. One of the things I'm thinking of as you talk about that is that even sort of method calls, the structure of that actually effectively makes them a data type and a data structure themselves. But if maybe you want to speak to at a high level some of the characteristics or opinions that Clojure has as a language that differentiate it, and maybe with some foresight that we'll eventually be getting into how that is a sort of compatible and good fit for some of the things Fluree does. But maybe tell us a bit more about what makes Clojure distinct, either from other Lisp languages or object-oriented languages, or whatever the case may be.
So I can start with what I mean by concision and elegance. So if a good example, so the first time when I was talking about Scheme, that was actually in a computer science class. And at the end of the class, we implemented a Lisp interpreter. And it was definitely an intensive project, but if you told a computer science student in their first computer science class to implement a Java compiler, it would be impossible, because there's so many different rules about how, if you call a function versus a method, where the arguments are, what if statements mean, what they do, and there are a lot of special cases, and they're not a ton of general rules that apply in every case. Whereas the structure of Lisp is, everything is just a function call, everything is a list, and the first thing in the list is the function, and then everything else in the list is the arguments of the function. And you see that pattern repeating over and over and over again in so many different cases in how you use the language. So when you're trying to internalize the rules and how you evaluate Lisp code and how you write Lisp code, there very few, just a handful of rules and even less special cases, and then everything else applies the same way. And then the nice thing about Clojure is that it takes that same idea, but then adds a few more data types. So instead of just everything just being a list, you have lists and vectors and hash maps and all the other things that you've come to you're used to from other languages. You can still apply those in Clojure and use the same ideas from Lisp. And so that makes it, in another way, productive language. The other thing that's interesting about Clojure is that, so in programming language theory, there's an idea of an abstract syntax tree. And so whenever programming languages have to fulfill two roles. It has to be easy for the computer to execute, and it has to be easy for a person to understand. And so the way most programming languages accomplish this is they have this intermediate representation where the language itself is the part that's easy for the computer to understand, and then there's machine code that's easy for the computer to execute, or the language is easy for the person to understand, and the machine code is easy for the computer to execute. And then there's a thing in the middle that the compiler or the interpreter transforms the language into the syntax tree that allows it to then transform the machine code. But there's this middle representation that distills the control structure of the language, and that extra representation adds a bit of complexity in how the program actually works. And the beauty of Lisp is that there is no abstract syntax tree. The structure of it itself is its own abstract syntax tree. So when you're thinking about how is the computer going to interpret this, there's one less hoop that you have to jump through to try to unwind how the computer is going to evaluate it. Is just the language and the machine code, no intermediate representation. And so that removes a good bit of complexity, and at least when it comes to your understanding of what the computer is going to do when I write this. The other thing that I appreciate about Clojure with respect to, or at least in opposition to object-oriented language, is that there's an idea of an object as this thing in the world that controls a lot of state inside of it. But it's not something that you can see. It's not something that you can manipulate. You just tell it, hey, do this or change that, and it does it for you under the covers. And that seems great when everything works well. But the problem arises when you've got a lot of different things asking that object to change all at the same time, and then those different interactions have different subtleties where you can have a bug where one thing changes one part of the object, but another thing changes another part, and those two changes don't really mesh well together. And then when you're trying to figure out, all right, what happened here, it's really hard to pull those covers out to see what's going on. And so a lot of times the things that make it super easy at the beginning makes it really, really complicated when one small thing goes wrong. Whereas with Clojure, everything is explicit. Everything that happens is something that you can see. So when you change something, you see, okay, that thing changed. And when you have a problem and you see that there's an issue that has arisen, then you say, okay, what changed since this, what change caused this, or what are all the things that changed since I knew the system was working well. And so it's a lot easier to unwind what's happening because everything is explicit. There's nothing that's hidden from you, and there's nothing that goes around manipulating state at the same time. Everything, whenever you make a change, you make a change for everybody to see. and it's all at once, so that there's no situation where you can get this weirdly updated state that is not refreshed for everything else. And so that explicitness is another thing about Clojure. And these are more philosophical ideas about how you build a programming language, but Clojure and the architects behind Clojure, they've internalized those philosophical ideas and made the language so that those things are explicit in the language. And yes, you can have mutable state in Clojure, and you can build object-oriented like systems in Clojure. But the way the language is designed, it makes it really difficult to do that thing, and it guides you in a way of explicitness and atomic state updates, so that you know. So that the easy thing to do is usually the thing that's going to cause the least amount of headaches.
Yeah, so there's two things you said that I want to pin. We don't have to talk about them now. We can come back later, but I'd love to think more about how what you described as like the concision of Clojure, the sort of ability to do away with a lot of the abstraction between the actual code you're writing and the actual machine execution of it. Because I'd love to think about that in terms of our smart functions, right? The code logic that we embed as data with the data itself, and what that might mean for the security of those invocations, for the guarantees that they're in the sort of process of abstraction, that you're not going to invoke something that might have disastrous consequences for the data. So I'd like to think about that in terms of smart functions at some point. I also would love to think about some of what you were describing in terms of the explicitness of state and the traceability of an order of operation of changes, and say like race conditions in a database, or sort of ACID compliance in terms of atomic updates to that data. But more generally, I want to give you an opportunity to answer, as you came to Fluree or understood what Fluree was doing, as you started to work with the code, I'd love to have a sort of perspective where these two things meet, where maybe you could speak to all the things that you were experienced with in Clojure, all the things that you loved about it as a programming language, and how you saw sort of immediate and obvious synergy between the problems we were solving or the capabilities that we were opening up. How did you sort of begin to approach Fluree and have a sense of the benevolent weddedness of Fluree with Clojure as a programming language?
So previously in my career, I had a lot of experience building big data platforms using MapReduce, the Hadoop MapReduce framework. It was a big data analytics platform where each day you had new events coming in, and you had to use Hadoop, which was based on Java, to ingest those new events and to show here's what changed today or over these periods of time. And that Hadoop is a really effective ecosystem, but at the end of the day, it was still using the same mutable. It was a functional, explicit framework in MapReduce on top of a mutable language, and so often it felt like there was there was a mismatch there, where a lot of the ideas that you used in when you're writing Hadoop pipelines didn't seem to really fit the language. And then after that, I spent some time building a distributed ledger from scratch using Go. And again, Go is an exceedingly powerful language, but there's still the notion of managing and manipulating state in a way that does not seem to jive in my mind with the understanding of values of specific items as time passes by. A lot of these other language paradigms ignore time. And so if you're saying, what is the answer to this question? They just give you an answer. But a lot of times the answer to the question depends on what time it is that you're thinking about or you're considering. And by ignoring time, you have you have the potential to come into a lot of those race conditions where you ask a question, you have to make a change depending on what the answer to a question is, and then you ask the question, a millisecond before, and you get one answer, and then a millisecond later, and you get another answer, and there's no way to say, no, I want to zero in on this particular thing that I'm worried about. And so because of that, you have these weird issues. When I heard about Fluree and I saw that it was building a distributed ledger, or it was building a database on top of a ledger in Clojure, I felt like those things matched really well. So it's almost it's definitely inspirational at this point. It's almost religious. There's a talk by Rich Hickey, who is the architect of Clojure, called one, there's Simple Made Easy, where he talks about the idea of understanding how you manipulate state and making sure that you do it in a way that is simple, meaning it doesn't involve a lot of different components that are intertwined. Uh, and then there's another one that he gives called Are You There Yet? Which completely changed the way that I think about software, in that you could have a system where it's an object that changes values at whatever time, and you ask it a question and it just gives you an answer, and it's like whatever. And that's the issues that come from that are the ones that I described about all the race conditions and everything. But then you could also think about the system as a sequence of static, unchanging values that change as time passes by. And you add time as an explicit parameter to your system, so that when you ask a question, it's not, what color are you? It's what color are you at time X? And when that happens, a lot of complexity just falls away. And you can think of time ticking by the as state changes as time ticks by, and time is an explicit parameter. And that to me sounds like a ledger, where you have a value of the ledger at a particular time, and then there's another transaction that changes a ledger, and you can treat that transaction as a clock tick, and that's a new time and a new value of the ledger and a new value of the ledger, so that you can go, if you want to go back and say, wait, how much was in this person's account yesterday? You can figure that out easily, because all of that information is explicit. Whereas in an object-oriented system, you would have to go back and, try to rewind or unwind the transactions, maybe look at your logs, maybe say, okay, well, my backup said that it was this at a certain time, and then I have logs that says that these events happen, so now I can push these in and see if my test system matches my production system and everything. And you have to jump through those hoops when those things are when time isn't explicit. But when time is explicit and it's an explicit parameter, then you could just look at what you need to find, and a lot of the complexity just falls away. And so the fact that a ledger was being built on Clojure, that to me is exactly the use case in Are We There Yet that Rich Hickey described. And so the philosophical synergies was definitely there. And then because Clojure was designed with that philosophy in mind, then there are a lot of just practical things in the language that makes doing that easily. Like I said, every language or every software problem is going to have to handle state. Every software problem is going to have shared state. But in Clojure, there's facilities to share that state in a way that's still explicit, so that you know what the value is at a certain time, and you can keep track of it easily. But you could still do all of the state management that you would expect in a modern language. And so what from watching the video, Are We There Yet? Once I said, oh wait, you're building a ledger in Clojure, perfect.
And it is. I mean, um, I should mention, I suppose, for the folks who on the call who might be familiar with Clojure but not with Fluree, this is one of the sort of fun or fascinating things that we're able to do, and a critically important one for a lot of our developers and clients. That we do have a sense of time, where time is sort of a first class citizen in the world of data here, so that you can do both both of the things you described, Ben, right? Which is to say, you can effectively understand every data state change for a particular set or subset of data over time, and sort of prove that back because of the immutability and the sort of time indexing of that ledger. But you can also ask questions of every single moment in time as if every single moment in time or every single block in that ledger is itself a fully queryable database. I should say it is a fully queryable database. And I guess I should mention to everyone on the call that part of that is because of Ben's work. He spent extensive amount of time in our the sort of indexing part of the under the hood engine of what Fluree does, and a lot of the value. If any of you are using Fluree, I mean, and you are, whether or not you know it, but anyone using Fluree and taking advantage of Fluree's sense of time is taking advantage of work Ben has done on our code. So, a small kudos to you for that. Um, I suppose I one of the things I want to talk about too, as you're talking about the synergy between Clojure and Fluree, would also be, if there's folks watching or listening to this who are familiar with Clojure, they're probably also familiar with Datomic as a data platform sort of built on and for Clojure. And there's a lot I think to be said about how probably the Datomic user base is a single, circle overlap with the Clojure user base, that there's not really anyone outside of Clojure using Datomic. Whereas, we'd like to think that Fluree is as universal as possible for its users. But I'd love to dive in a little bit to, your sense of, at a very high level, because we're not Datomic, but what Datomic is, and then maybe to speak a little bit too about for anyone familiar with Clojure and Datomic, what Fluree does that might be similar, or where there's sort of shared values, or would be a shared understanding, but how Fluree sort of stands out or is distinguished in some way from that platform.
Sure. So yeah, Datomic is a powerful database, and it has a lot of similarities with Clojure, or with Fluree architecturally. So they're both what we call triple stores, where they store data in they store relationships between different bits of information. So we use slightly different vocabulary. So in Datomic, I believe they call the items in the database entities, and then the relationships between those items attributes, and specific values for those attributes. They call them values. And in Fluree, we call them subjects. Items in the database are subjects. The relationships between those items are predicates, and the values of a particular predicate is an object. They both treat data changes as specific snapshots and changes in snapshot changes over time. Time is a first-class citizen in both databases, so you can query both databases as of a specific moment of time, both going backwards and going forward. If we transacted a bunch of this database, now you've got something in the future, but you don't have to commit it, then you can query that, as of this time in the future. You can do both those things in Datomic. I would say the differences between Datomic and Clojure and Datomic and Fluree, and what Fluree brings that Datomic doesn't, is that Fluree also has a cryptographic verification of each change point, whereas Datomic doesn't. It's a database where you could just add information. As long as you have access to the database, you add information, and then who made that change, or when did they make that change, did they have the ability to make that change, and more importantly, as a consumer of the data, can I verify that the changes that have been made to this data, or the database itself and how it's been managed, can I verify that no unauthorized person has made any changes to the database? So Fluree has a blockchain within the database itself. So it's not a blockchain in the same way as Bitcoin, but it is an internal blockchain to keep track of the consistency and the provenance of the data, to make sure that everyone who changes the data has the right permissions to make those changes. And more importantly, I think it allows anyone who consumes the data, if they care about the provenance of the data, to make sure that the data is valid for what they're looking for, they can verify that the only people to ever have changed the data are the people who had the permission. And similar to that, there's an idea that Fluree has introduced called smart functions, where we used a lot of what I was talking about in previously about the elegance of Clojure and how there's no such thing as an abstract syntax tree in Clojure. Is just the code that you use itself. And so in Fluree, you can actually embed Clojure or Clojure-like code in your database itself, and then you could use those codes during a transaction to evaluate, does this person have the privileges to do what they're trying to do right now, or is this person able to access the data that they're trying to access right now. And the reason why that was so great to do with Clojure is because, if we tried to embed Java or Ruby or whatever other language, then we would have to have an interpreter that's creating an abstract syntax tree and that's doing all the things underneath the hood in a performant way that is possible, but really, really difficult, error prone, and easy to introduce security problems, because you can't have a language like this be too powerful, but you want it to be powerful enough to be able to express everything you can. But because of the way Clojure works and the way the language is structured, so that there's no the language is a language and the language is an abstract syntax tree as well. It's easy to define a subset of the language that can be evaluated by the process itself, such that it is both secure, so that you can't do it's not too powerful so that you introduce security flaws, but it's powerful enough so that users can express what they want to do. So I think the two main benefits and differences between Datomic and Fluree are the smart functions and the cryptographic verification of the data state.
And two other things that I actually was thinking of as you were talking as well. The sort of intended, use case and sort of user story around Clojure and Datomic is still one, right, where um, Datomic is effectively being wrapped by an application written in Clojure. It feels very much like you're just writing Clojure in the use of it, but it still is sort of an application-centric idea of what a data platform is able to do. So I think it's one other piece, and maybe this gets to some of the more data-centric security you were just describing that's really important to Fluree, is that Fluree does still look to solve this problem and sees itself as uh, um, or seeing the future of data as needing to solve the problem of what does it look like when you need to have multiple producers of data, multiple people writing to a data platform, not just the one sort of specific application that's contributing to it. So a lot of, I guess, the cryptographic provability of that data, a lot of the ability to embed security into the data itself is also built with the idea that Fluree needs to have multiple producers and consumers of data, not just a specific application or one specific application. How do you do that? How do you expand that sort of access? And a lot of that comes down to guaranteeing the security around the data and interactivity itself, or guaranteeing the security at the data layer itself.
And to piggyback on that, one nice thing about Fluree is that usually, if you've been writing software for long enough, you end up having a database with a bunch of information in it, and then you stand up an application server in front of that database to manage the access controls and the security. And then after that, you have a lot of different interfaces that are making requests against that application server to be able to say, okay, display this data in a certain way, but make sure to check the person's credentials to understand that they have the ability to access the data. The nice thing about Fluree is, for that simple use case, you don't really need the application server in front of it, because Fluree itself can enforce a lot of the security that you would have to hand roll with the application server. And so that's a convenience for that really common use case where you need to make data available, but you don't need to make all of the data available to all of the people.
And also, I don't know if you'd have anything you'd want to say about this, but I do think it's, both Fluree and Datomic use the sort of triple store, like foundational syntax for how to describe data at a fundamental level. But, it's worth mentioning that for Fluree, that triple store is based on the sort of W3C RDF standard. And that there's important differences, I think, there and how that um, opens up data in Fluree to more of a, interoperable or open data ecosystem utility, right? That the data is not just in a triple store, but that it's also self-describing, or can be self-describing, can be sort of machine readable, um, and that it opens it up to sort of, distributed queries across data that's described using, common syntaxes or vocabularies that can effectively intuit one another. Um, I was talking to a sort of Clojurist once who sort of felt as if Datomic had like invented the triple store. um,
Sadly, I thought that too before I ran into Flurry, because it was the first exposure that I had with triple stores, and data log is their implementation, and I thought it was brilliant, and it is brilliant. And I remember chatting with Brian before I joined, who's the CEO and founder of Flurry, and I was telling him how brilliant I thought data log was, or the data log implementation used by Datomic, and he pointed me to all these W3C standards where you could tell that they got the inspiration of data log from those standards, but then they made a number of different changes, and I wasn't there when they were designing the language, and so I can't say why they made these changes necessarily, but I will say that there is a lot of power in using open standards, because that enables the interoperability and it doesn't have the same kind of vendor lock-in. And so when you use something like Flurry, you can deploy it and create APIs that anyone can use and anyone can consume. And as you said, it's self-documenting. And so if someone trying to build a system as flexible as possible and connecting especially if you're trying to build an open ecosystem of data, using open standards is way more desirable in my opinion. And so the fact that we still have this a very similar, especially if you're someone who comes from the Datomic world and you start using Flurry, it seems like you're at home, but you're using an open standard, and that standard is already documented and is already accepted, and so it's something that you can use in a much wider array of different use cases, and you can trust that you'll be able to interoperate with other systems built using the same standards.
we're coming up. I want to make sure that we do leave time for questions. So maybe the last thing I'd want to just ask you your thoughts on is, Flurry is open source, and all of our code's visible and available online on our GitHub. If anyone's interested and hasn't had a chance to dive into that, especially if you're a Clojurist. And I think we're working actively on making sure that our resources and support for open source contributors are more consolidated and better documented. But whether it's now or in the near future, if there were people watching this, or if there were Clojurists out there who wanted to know, where could I maybe start, or where would be a space where I could possibly meaningfully get my hands dirty, but consider, contributing in some way. Where do you see Flurry as Clojure code having the sort of on ramps for Clojurists to begin to get involved in? I have a few thoughts that I could check with you to see if you thought that they'd be worthwhile, but I'll start and see if you have any initial thoughts off the bat.
So my initial thoughts are, so anything that anyone wants to dive into will happily take a pull request from anywhere if anyone wants to get involved. So don't take what I say as you must be limited to these things. Like, all of our code is open source, and if you dive into anything and you see some way you can make it better, we would welcome it. But I do think there's a lot around our consensus algorithms, and we have a an independent Fluree raft library that I think we could both improve the raft implementation, but also if you want to try to add in another consensus algorithm, that'd be great. So if you use the same interfaces to speak with the main Flurry process, and you want to do I don't know, PBFT or something like that, so that we could have to play around on how consensus works in that way, that would be great. That's something that I would like to tackle, but we have a roadmap and everything else that we have to focus on first. I do think we could use client libraries for other languages. Right now we have Clojure script slash JavaScript Node and Node.js library, and we have a Clojure library. If someone would like to use those libraries as a starting point to build something like a Ruby library or another language that you would appreciate, I think that would be great. Or taking a look at the libraries themselves and improving those. That would be a good place to start. And the other is just our meat and potatoes core DB library that holds all of our functionality. It's quite a large library, and we are planning on trying to pair off some of the functionality and make those independent libraries as well. But if you want to really, get down into the middle of it, that's the place where you want to be as well.
And maybe one final sort of small question. Well, I mean, maybe it could be a big question, but with the goal of maybe a 3 or 4 minute answer. Um, looking both towards what you hope for the future of sort of Clojure as you see both that sort of baseline language grow, but also maybe the ecosystem of support and tooling around it, or alternatively, just sort of in our pathway forward, the roadmap that we're working with internally for the future of Flurry. What are some places where you see sort of additional like excitement and possibility as those expand, maybe particularly insofar as Flurry is infrastructure product built on Clojure.
Sure. So with Clojure, I'd like to see more platforms. I think the beauty of Clojure is that it is a hosted language, so it's able to piggyback on ecosystems that are already developed, and so that makes the bootstrap process for a new language much easier because of the ecosystem concerns that I was talking about. So right now we have Clojure ports on Java, JavaScript, the .NET framework, and I believe that is it, but there might be one or two more. So I would like to see Clojure on mobile. There's a lot of difficulties in implementing that, but if we allow Clojure to run natively on mobile devices with good performance, then that unlocks entire ecosystems in Clojure. As far as Flurry is concerned, one thing that is exciting to me is the idea of decentralized Flurry, where people can have you have people who are producing data in a lot of different places, storing them in a lot of different places, giving whoever access to them, and then you have other people consuming the data and combining the data together, and so that you're able to on the fly build up these rich data sets with lots and lots of different sources from both big governmental institutions to big companies to some guy with a weather meter on his roof that's publishing data out. And me as a consumer, I can build applications that go out and find these data sets and use Flurry libraries and Flurry infrastructure to be able to gather these data sets together in a way that I can query about this data in a performant way that weaves all these things together, so I can say, well, let me use this guy's weather data and see if the factory down the street from his apartment polluted a bunch that day, and then it made it, and it changed the weather, as a contrived example that I come up with. But allowing allowing the different data sets, someone who doesn't know how the data is going to be used, but they can just publish it in a format that Fluree can read, and then someone else who doesn't know what data is out there uses Fluree to go out and explore and say, hey, what's out there? What can I use? And then weaves it together and is able to answer relevant questions from all of the data coming together and being used in a coherent way. I think is really exciting. I think is going to enable a whole new generation of applications that we can't even imagine right now.
Um, well, I mean, as someone who has a good sense of how sort of like Flurry has been built on Clojure and what that's added, I still have appreciated this conversation. There were several pieces of this that I didn't even, you know, I hadn't even been thinking of that generated new insights for me about what it makes Flurry able to do what it does. But I think I have unmuted on a server level everyone in the channel. So you should, if you have any questions, be able to unmute yourself now. If anyone has anything that we've discussed that you'd like to hear more about, any other specific questions that are in some way relevant to the topic, would love to open up some Q&A from anyone who's here. And if you can't unmute yourself, feel free to just type into voice chat, text, or into the general channel. But I do think everyone should be able to do that now.
Hey, for everyone listening in on the stream, we're gonna end the stream here. And if you do have questions, I'll encourage you to follow the link on the screen right now. I'll leave it up. But just for everyone listening, we're gonna end the stream here.